Example 6, we've got a diagram that shows a straight section of a river, 1 kilometer wide. Adrienna is at the point O, and she wishes to reach a point B on the opposite bank. The point A is directly opposite O, and the distance from A to B is 2 kilometers. So the idea here is that Adrienna can row at 6 kilometers per hour and jog at 10 kilometers per hour. She intends to row in a straight line to a point P on the opposite bank and then jog directly from P to B. And we want to let the distance from A to P be equals to X. Okay. Show that the time that Adrienna takes to reach B is given by T is equals to root X squared plus 1 on 6 plus 2 minus X on 10. So diagrammatically speaking, we know that the distance from O to P, okay, represents how far she has to row, and the distance from P to B represents the distance that she has to jog. So what that means is that if I let the distance from A to P be equals to X, and I know that the river is 1 kilometer wide, so from O to A, that's going to be 1, then the distance from O to P can be found using Pythagoras, right? So by Pythagoras, so this is part 1. So by Pythagoras, we should be able to see that the distance from O to P squared is equals to 1 squared plus X squared, right? Or in other words, the distance from O to P is equals to root 1 plus X squared. And the distance from O to P represents the distance that Adrienna has to row. So the time that she takes to row from O to P is going to be the distance, 1 plus X squared, divided by how far she can row. And the question tells us that she can row at 6 kilometers per hour. So we're going to take this and we're going to divide it by 6. So that's going to be the time it takes for her to go from O to P. Now, when she wants to go from P to B, okay, take note that from A to B, that's going to be 2 kilometers. If the distance from A to P represents X, then the distance from P to B is going to be the difference between them. Right, so that's going to be 2 minus X. So we know that the distance from P to B is equals to 2 minus X, which means that the time it takes for her to jog from P to B is equals to the distance 2 minus X divided by how far she can jog, and we know that she can jog at 10 kilometers per hour, right? So from this, we know that the total time it takes for her to now go from O to B, okay, or the total time of the journey is simply equals to the time it takes for her to go from O to P plus the time it takes for her to go from P to B, and that's just going to be equals to root 1 plus X squared over 6 plus 2 minus X over 10, right? So that's essentially the total time of her journey. Now take note that for some students, this is actually very, very intuitive, okay? And they can essentially figure it out from the very beginning, okay? Then they go, okay, Pythagoras from O to P, and then from P to B, that's just 2 minus X. But what I just want to point out over here is that no matter how obvious it seems to you, always include a little bit of the working out, especially for questions like this. Because if you just jump the couple of steps and you don't show working out and you go, okay, time is equals to that, and that's essentially like pretty much literally the only line you write, then the problem with that is that the examiner would have no idea that you have actually done the question, okay, because the question asks you to show, right? So the solution, or in other words, the formula is there already, and if you just write the formula down, even though you have kind of like worked it out in your brain, it's not actually showing anything, so you're not going to get the marks for it. Okay, so especially for questions like this, make sure, okay, that you write some working out so that the examiner can see what you've done. Okay, that's extremely important. Now, part 2, we want to show that if Adrienna wishes to minimize the time taken to complete the journey, then she should row to a point P, which is 3/4 of a kilometer from A. So we want to, in other words, show that X is equals to 3/4. So take note that the goal here is for Adrienna to minimize the time taken. And that's really the dilemma of this question, because the easiest way is obviously for her to go from O to B directly, okay? But then she has to row the whole way, okay? And the thing here is that she can jog faster than she can row. So from a time perspective, okay, it's actually a lot easier for her to run a portion of the distance. So we know that distance-wise, right? It's always best to cut corners, okay? So she wants to row a little bit, okay? And then she wants to jog the rest of the way. And obviously where we make the trade-off of how much to row, okay? Because the more she rows, the more distance she saves, okay? But then remember that she can't row nearly as fast as she can jog, okay? That's why she has to jog a remaining distance so that the time taken for her journey is as small as possible. In other words, she wants to get to her destination as fast as possible. Now, of course, we don't have to think about it too much. The standard process here, if I want to minimize time, is I've got the time function, and all I need to do is differentiate it and solve the derivative equals to 0, and of course justify why the answer we have is actually the correct answer. So before I differentiate this expression, I'm going to rewrite this slightly. Okay, so part 2, I'm just going to take note that this expression here can be rewritten as 1/6. The square root of 1 plus x squared, I'm going to write as 1 plus x squared to the power of half. And then the fraction at the back here, I'm going to break it up. So this is going to be 2 on 10 minus 1 on 10x. Okay, and the reason for me rewriting the expression in this fashion is just that it's a little bit easier to differentiate. For example, dt dx here, if I look at the first term, the 1/6 times 1 plus x squared to the power of half, I can just use functioning function rule. So we've got 1/6 stays out at the front, and then the 1 plus x squared to the power of half, I'm going to take the half down, subtract 1 away from the power, and then at the end, I'm going to multiply by 2x, which is the derivative of 1 plus x squared. Now, if I differentiate 2 on 10, I'm going to get nothing. If I differentiate minus 1 on 10x, I'm going to be left with minus 1 on 10. So if I simplify things a little bit, the half and the 2 cancels away. What I have left here is x on 6 root 1 plus x squared minus 1/10. Okay, so that's going to be the derivative. So just going to start a new slide here. Okay, we know that dt dx is equals to x on 6 root 1 plus x squared minus 1/10. Okay, so the first thing which we're going to do is we're going to let dt dx equals to 0 for minimum time taken for her journey. So I'm essentially solving x on 6 root 1 plus x squared minus 1/10 is equals to 0. Now, there are a couple of ways of solving this equation. The easiest, in my opinion, is to move the minus 1 on 10 to the other side. So we have x on 6 root 1 plus x squared is equals to 1/10. And once I've got this, I'm going to cross multiply. So the 10 gets multiplied with the x, and the 6 root 1 plus x squared gets multiplied with a 1. And that's going to give me 10x is equals to 6 root 1 plus x squared. And now, to get rid of the square root on the right-hand side, I'm going to square both sides. So if I do that, we get 100x squared is equals to 36 times 1 plus x squared. If I expand the right-hand side, we've got 100x squared is equals to 36 plus 36x squared. Collect the x squares together, so 100x squared minus 36x squared gives us 64x squared is equals to 36. If I divide 64 across to the right, we're left with x squared equals to 36 on 64. And of course, if I take the square root of this, we're going to get x is equals to plus or minus 6 on 8, or in other words, plus or minus 3 on 4. Now, given the context of the question, where x represents the distance from A to P, we know that x has to be greater than 0. Okay, so since x has to be greater than 0, the only value of x which we're going to take is x equals to 3/4. Now, even though this is the solution that comes out, we haven't quite justified why this value of x actually gives me minimum t. So we need to show that this value of x actually does give me minimum t. So that comes out fairly easily. All I have to do is test. So what I'm doing here is I'm going to test x versus dt dx. I've got 3/4 in the middle, which is going to give me a derivative of 0. I'm going to test 0 to the left and 1 to the right. dt dx is given by x on 6 root 1 plus x squared minus 1 on 10. If I substitute 0 into this, I get 0 divided by something minus 1 on 10. So I know that it's going to be negative. If I take 1 and I substitute that in, I get 1 on 6 root 2 minus 1 on 10. If I type that into the calculator, it's going to be a positive value. And what this shows me is that for this stationary point here, okay, the gradient on the left is negative, then 0, and then it's positive. Okay, and once we're able to show this, we can then conclude, therefore, for the time x function, okay, time is minimum when we choose x to be 3/4. Okay, so t is minimum when x equals to 3/4, right? And then we can conclude that if Adrienna wishes to minimize the time taken to complete her journey, then she should row to a point P, which is 3/4 of a kilometre from A. And this concludes example 6.